Welcome back. So once again, we're going to be doing this part right here on SolidWorks. Now, when you start a part, any part as it is, you're going to obviously start with a sketch. It is important to note that when you're building this part, and this is not cloud-based, so you got to save it to a right location and name it fine, and save often, as I say. There's nothing worse than getting halfway through it and having some sort of glitch and everything crashing on you. So I'm going to start a sketch, and I'm going to start it from the front plane because I like my XY coordinates to be nice and even. You can do either a corner rectangle. I'm kind of prone to these center rectangles where you start right at the origin and it comes out from the center. Just different way of building it. Could you done a corner? It works the same way. So I just did a rectangle. I'm going to add some constraints or dimensions to it. Looking at it from the front, the total height is 0.84. Now, the interesting thing is, because I'm going to be giving you these drawings fully dimensioned, the height on the front, the height on the bed, everything has to be 0.84. And if you follow the directions, you'll be fine. But you would be shocked how many times I have students pass in parts that were all different heights. Like, the car is supposed to connect together and they're all supposed to be the same height. How did they not become the same height? You never went back and checked to make sure that your cars are all the same height. Just interesting things that you run into. Right there. There's my basic block. We're going to extrude boss base. It has already found the profile. Profile looks good. And the depth, according to this, is 0.75. Excuse me, 1.75. It's a square block. For some reason that doesn't look right to me. 1.7. Yeah. Okay. Now, as we are working on the next section, where do we begin? That's a good question. I usually start with something simple, build the confidence up, right? Or better yet, file, save as, find your folder, section 9. I'm going to save it right in here. I'm going to call it center. Sometimes I actually put RE, center, truck, and then there. Now that I have it, it's right here. It's not going to go anywhere. You may even want to, create a folder with all that stuff right in there. So now I'll do another sketch. Sometimes I just click on the surface. I add the sketch here. I'm going to look at it from the top. I don't like the way that moved on me. There we go. I got my sketch on there. I'm going to do 2 circles. These are the holes for the top. This is the holes for the windshield. Notice I don't pay any attention to where the circles are, what size the circles are. It doesn't really make any difference to me because I know I have to put on location dimensions and size dimensions. I have to constrain it. So I have to constrain it down so that this, from here to this center point, smart dimension, it states that it's 0.85. Now, this is kind of interesting. I could do the same thing to the other side. I could add another dimension, or I could go back and add a relationship, add relation. I pick this center, and I pick this center, and I could say I want them to be vertical. And notice they line right up. That add a relation just saves you from dimensioning. It does the exact same thing. The good thing is, I guess, if I move this dimension, it would actually move both of them because now they have to stay vertical. So I added that relation. So the next step would be to do another dimension from the front edge back. That looks to be 0.55. And I'm going to do the same from this side, 0.55, to make sure they're the same distance. By the way, this is probably the most important dimension. And the reason I say that is because when you line these up with the pegs, sockets in the back and the pegs on the front, they all have to be exactly the same. So it's important that they are. Otherwise, imagine that if you have all these parts built and none of them line up. It says that this 0.4, and you can either dimension that with a size dimension, or I can go back and do my relation and say, I want this and this to be arc. I must have went and didn't say add relation. Add relation here and here should be equal. Now they're same. So I didn't actually have to go back and dimension the other side. Once again, the good news about that is that if I ever change the value of this, the other one will change at the exact same time. So now that I've created that sketch, I have constrained it. I'm going to finish my sketch. I'm going to go back over, as we have done many times before, extrude cut. Now I'm going to go back and say, okay, let's see how far down this goes. There we go. 0.4, depth of 0.5 times 2. Times 2 is a reference. That means there's 2 of them. And that saved me from having to put another dimension on the back. So that's the kind of thing you can get away with if you're familiar with the dimensioning practices. So over here, it says blind hole already. I just got to specify my depth of 0.5. And I got my first 2 holes. Easy. And now I'm going to flip around to my front, and I'm going to build a peg. So I'm going to build a peg right on the front. I'm going to pick on the front so I can see it better. And this is how we're going to go with that. Pegs are just circles. Notice when I picked that, it automatically grabbed that center point. And that was okay with me because I do want it to be in the center. If it didn't happen, I would have to add a dimension. To be perfectly honest, I'm going to add this dimension just to make sure that I did connect with it perfectly. And that's exactly what it should have been, 0.42. So I don't have to even bother with it. It has to be, and remember what I said about this dimension? 0.55. Think about that. If there are sockets and the pegs are in different centers, different locations, your car is not going to go together. And that's not going to be much fun for you. So next, I'm going to do this is a dimension. And I always start with the biggest part of it. I'm looking around. It appears that the biggest part is 0.33. Finish my sketch. I always go back and look at it isometrically when I do my extrusions. Now this first part, it only extrudes out for 0.03, so it's not very far. 0.03. There's my first extrusion. I'm going to make another sketch right on that surface. Now, because I already have a circle there, it just makes it a whole lot easier to create another circle. If I come down and try to pick the center, it doesn't work, but I pick the outside. I don't actually pick it. I just see how it gives me the center now, and it will pick the center. It'll snap to the center. The second one, I know I don't have to dimension the location because I've got the center. The second one coming out is 0.25. Finish our sketch. Now I'm going to go extrude. As I'm looking at it, this one's going to come out. And once again, you got to go back and kind of make reference up here. So coming out 0.33 minus the 0.3, because I'm coming out from the front of that surface at 0.03, I think. So I'm just going to come out just 0.3. It said 0.33, isn't that funny? Check. There, I got part of the peg. I'm going to do the same thing over again. Repetitive. Back. Creating the same center circle. These are all concentric circles. This one's a little larger. This one, I think that actually is right. 0.28. Is it 0.28 exactly? No, not even close. 0.28. Finish my sketch. If you extrude it while it's not in isometric mode, then it just makes it difficult to really see are you going forward? Are you going back? In this case, when I go to extrude, I'm going to go back. So I'm going to switch directions. And the distance is going to be the same as it was on the front, or on the inside, I should say. So now really all I've done is 3 circles. This one's 0.33, 0.25, 0.28. That's all I've done is 3 circles. The next step would do another circle. Hard to believe, yes. Sketch. On the front, this is the one that's going to cut the hole out of it. And the hole that goes through is I think it's 0.4. Oh, excuse me, 0.20. So I'm going to confirm that that's correct. 0.20. And the depth of this, I keep going to that side. The depth of this one is going to be 0.5. Oop. See, I just did extrude. I got to do an extrude cut. There it is. It's funny that I didn't pick that out. Maybe I put that. Sometimes you bring your parts tree over here, pick on your sketch, cut 0.5. I thought it picked it out automatically, but maybe it didn't. So a lot of circles. 1, 2, 3, now 4 cylinders basically cut out when the last one was cut out to give you that shape. Now, it's all the little nuances that make it look better. For instance, if you look carefully, it says that there's going to be fillets all over it. So I can come up and I can use my fillet button. And I'm going to type in 0.01. And there's a series of 0.01 fillets. One here, one on the inside, and one here. And you can see that it's just going to round it over, making it look kind of cool. Look at the bottom of this hole right here. If you look at the diagram, the bottom of the hole is rounded. See that, how it's rounded on the bottom? And it says 0.1 radius. So I'm going to go back and I'm going to add that fillet. Change it to 0.1. And I could just grab that corner in the bottom and I'm going to fillet that. Not looking bad. The interesting part, see how it has this little groove right here? Cut, there's a slot cut in here. This is going to give that end of it a little bit of flexibility, so when it goes into the socket, it's actually going to push out and really hold it on there nice and tight. So this is a 0.04, and it goes through both sides of it. 0.04. Now, a lot of students think that's probably one of the hardest parts. The truth is, it's not hard at all. To do that, I'm going to look at it from the left side here. And I'm going to put a sketch right on this outside surface. Right click, add a sketch. And then remember this center point rectangle? Center point rectangle. I can still pick my center point, and I'm just doing a rectangle. Doesn't matter how big it is because we're just going to end up cutting it right out anyway. Boom, 0.04. And that's it. That's all you had to do for the sketch, which is kind of nice, right? Moving ourselves around a little bit. And then I'm going to go back. I'm going to finish my sketch. Extrude cut. Cutting into it. Must have a depth here somewhere. 0.2. Cuts in at 0.2. Cuts in 0.2. And check. So what looked to be pretty difficult, actually, if you use that center point circle, ends up being pretty straightforward. Now these are 0.4s to round the bottom. That's what I love about fillets. You can round a bottom with a 0.02 radius, rounded. Notice how I just picked the corner. And just picked the corner. And there you have your peg. Now, it doesn't look very good right now, so we're going to change the appearance of it. Some of you probably already know this, but if I select any surface on that, and I can go to Appearance, and it says Face, I just want to change the face of it, the face appearance. It allows me to pick a color. All these end up being pretty green. See how that picks? Well, I'm still in this situation. I can pick every single one of these faces, and it's going to, because they're all interconnected, turn them to a green color. The pain is trying to get all the different faces, the inside, outside. I'm picking every single face that I can see from this point of view, and then I'm going to move it, and I'm going to get all the ones I missed. As you'll see, I missed that face, and that face, and even this little tiny face here. Now, this is not changing the material at all. The material stays the same. What is changing is just the appearance of it. That's it. So I want to make sure I get them all before I hit yes. That's why it pays to move it around a little bit. Check. Yeah, that's looking better. And that would be our peg. Now, for those of you that are worried about having to do that again, guess what? You don't have to do that again. The one on the right and the one on the left are exact mirrors of each other. So we're going to mirror it over. Could we have done that with the holes on the top? We certainly could have. But it really isn't necessary. There are two very simple holes cut out at the same time. Before we can mirror something, though, we have to have a mirror plane that goes right down to the middle of it. So I'm going to go plane. It says, where do you want the plane? Pick the front. And then we're going to go around and pick the back. And notice it automatically assumes you want a mid-plane. Puts it right in there for you. Just hit check. And this is the fun part of it. Once you have the mirror plane, then you're ready to start to mirror. Now, when it comes to mirroring, I strongly recommend that you, well, it says pick the mirror plane first. So I'll pick the mirror plane first. Now it says, what do you want to mirror? Every one of these features has to be selected. That one. See how it comes, it actually appears. Every one of these features has to be selected. In technically no particular order, but once you have them all selected, how about this piece? What's that one? Yep. Once you have them all selected, you just simply say check, and you have the opposite side done too. Like I said, you got to work with the, you think about all the different ways you can make this move a little faster. The sockets are a challenge as well. They take not nearly as bad as the pegs, but the sockets definitely are a challenge. So we're going to start with a sketch on the back. I'm going to turn it around so we look at the back. And then I'm going to start with the circles. Now, I could do some reference geometry and pick the center to make sure that they're all concentric. And that's probably a good idea, just to make sure that this and this, remember what they're supposed to be, 0.55. They all have to be the same, 0.55, right? They all have to line up. This, from the bottom or from the top, shouldn't matter, should be 0.42. Because I hit center, it did it. And the first diameter we're going to put in, as we look at our part, now we're building this side of it. These sockets will be here on this side. 0.44 is the very outside, but that's not really the one we need to worry about or need to do. I want to say I'm looking at that. I'm just trying to see if there's a specific one. It's 0.30, so that's it looks to be 0.32. Once again, I'm going to make sure that all those dimensions, that's not the most up-to-date one right now, 0.32. I thought that was 0.33. Oh, I did see the dimension on the other side. It's 0.33. My apologies. So this time, I'm going to start out simply by cutting this out of here. Once I have it set in the proper position, I have my two location dimensions. I have my diameter dimension, and I'm ready to start cutting this out. So we go to extrude. And this time, interesting enough, it only goes in 0.02 of an inch, actually. Yeah, 0.02. Very tiny. There's your first cutout. Just like we've done before, pick that surface, add a sketch. I look at it from the right side. I'm going to drill another hole. I always try to make sure it finds the center there. This one is 0.26. 0.26. Finish your sketch. We're going to use our extrude cut again. Once again, we're building the socket in which the peg is going to fit. This one goes back 0.32. Cut. Now, on the diagram, it makes a really interesting little, it's almost like a countersink. So if we went back and look at our diagram, you'll see that it has just the smallest little a chamfer right here, like a countersink, it's 0.03 at a 45-degree angle. To create that, it's pretty simple. Instead of using our fillet command, which rounds things over, we're going to use our chamfer command. And look at that, 0.3, 45 degrees, must be at nose. And you just pick this corner right here, this corner. So it gives you that taper as it goes in the socket. And then we're going to add a fillet to the bottom, which is the same 0.1 fillet that we used on the other side, 0.1 fillet. Pick that bottom corner. Because this is a bigger hole, 0.26, it left a diameter right there in the center, but that's not a big deal. Now, this one has a slight recess on it, and so I'm going to do one more thing. It's really more for looks than anything. I'm going to put a circle sketch right on this outside piece. And look at it from the right side. Center. It's, like I said, it's a cutout, but it's a tiny little cutout. It's 0.44 from the center. And this time, just to give it a look, it's going to be a different surface so I can color it differently. I'm only going to cut it out. And it doesn't have to be much. 0.002, 2/1000 of an inch. And you'll see there's just the tiniest little recess right there. It gives you the illusion that something is drilled out and placed in there. Like the other side, I'm going to do the same thing. Notice I picked on it, and I come over to Appearance, Face, and I'm going to use the same green color, and I'm going to change all the surfaces to green. Even the tiniest little edge. Now, maybe I'll leave that one because I want to change that one too later on. Check. So now I have a peg, 2 pegs on this side, and a socket on this side. Once again, because the part is symmetrical, we can use our mirror command. We'll scroll down to the bottom because all of my parts that I just built are kind of down to the last pieces. The first thing you want to do is pick the mirror plane. Pick the mirror plane. Whoop. And then you want to pick all the little pieces you built. So pick that, that. Now, sometimes you have to hold your shift down to pick multiple parts to it. And you can see it all coming together there. I don't really need to. And now I have 2 sockets. Now, if I'm done with my mirror plane, which actually I'm not done with my mirror plane, I'll show you why in a couple minutes, but when you're done, you just right-click on it and change the visibility so you don't see it anymore. If you try to get rid of it, then it's going to get rid of your mirrors, so it's not something you want to get rid of.
Could you quickly go over how you got how you got that plane there? I missed that part of it in the very beginning when you.
Yep. It's quite simple, actually. You just kind of go to Reference Geometry, Plane, and then pick this side, and then pick the other side. And I love how it's intuitive in the sense that if you pick 2 planes or 2 surfaces, it's going to put the plane right dead center in the middle.
Okay.
That's it.
Cool. Thank you.
Yep. So now, when we're looking at it here, we got to add some fillets on all the corners. All the corners are filleted. Obviously, it's some sort of a kid toy, so it's got to be safe. You don't want those edges on it. I think it's 0.13, not 0.3. 0.13. Pick. Notice I pick all this one. Some people do a fillet and they'll pick one side at a time, but whoa, check that out. When I picked that flat surface, it picked them all, right? It picked that face. I'm going to clear that selection and I'm going to go back and start again. That corner, and then I'm going to pick this corner and that corner. Once I have all 4 of my corners selected, I'm going to fillet them all. Now, believe it or not, there's this really tiny little thing right here. A lot of students miss it. There's a little groove cut right across here. It's so small, it's hard to see, but I'm going to go back. I'm going to add a sketch to that front surface. Now, if I'm cutting a groove, a very small groove all the way across there, I'm going to use corner rectangle. And notice where I started. I'm just going to kind of line it up here. I'm dragging it all the way across. Like that. There's a groove on both sides of this, all the parts, the back, the front, everything has a groove through it. This groove, when I say small, it's definitely small. The groove is 0.01. So it's tiny, and from the top down, it's the same distance as the radius or the fillet. It's ever so small there. And when you cut it out, now notice, because I'm cutting it away, I didn't care about how far out it came. A lot of people are trying to cut it and make their rectangle starting right on the edge. But remember, whatever we extrude or cut out of there, it doesn't matter if I cut it out of space over here, it makes little difference. So, and you can see that the distance going in is going to be minimal too. I want to say 0.01 deep, 1/100th of an inch deep. And it leaves that little tiny groove right through there. And as I mentioned before, I could cut that out on the other side, or I could just go to mirror, pick your mirror plane. Sometimes you have to open up your parts tree to be able to see the part that you want to mirror, that last cut, right? Let's see. Pick. There it is. And see how I cut it out on both sides. And because I'm just about done with this part, I'm going to go back up to my plane. Here's my original plane. I'm going to turn off the visibility so I don't have to see it. And to give your part the realistic look that it needs, they're actually made out of a hard maple. So I'm going to go back and I'm going to go edit material. Let's see, wood, maple. Maple has a lot of nice properties. We're going to hit apply. If I can get. There it is. It actually makes it look pretty darn good. And that would be the center part of your Automoblocks reverse engineering project. Most importantly, save. You know, because, you know, these programs take up so much space that they do tend to crash a lot. So, oh, by the way, I didn't mention this at the beginning, but you always want to double check your inch, pound, seconds. God forbid that you started out in millimeters and then everything would have been messed up there, right? So that is how we are going to construct our parts. Next week, I'll be showing you some of the other parts and how you can derive a part from this part, which actually makes it easier. But That's what that is. Any questions?